So today I'm going to talk about object-oriented programming. Object-oriented programming is a computer programming model that organizes data around objects instead of functions and logic like how it is in structured programming. It virtualizes the real-life scenarios into the program. So for example, in our previous program, Swing Adventure, we tried to create a game where a player can locate items inside the game and they can fetch it and put it in their bags. And so for the purpose of this game, we virtualize the world as a module, and then we start to think about what would we need inside the world. Maybe trees, fire hydrants, bananas, bags, glasses, and of course the player itself. Every object in object-oriented programming knows things and do things. This is what we call the concept of encapsulation. What knows things is usually defined within its fields, whereas do things are usually defined as its functions in the program. Although we try most of the time to recreate or imitate or virtualize real-life objects. For example, in this case, we try to virtualize student as a player. We do not virtualize everything that a student are able to do. Well, students are able to study, students are able to think or breathe, but we do not put it as a function inside this. Choosing what an object knows and what an object can do based on the purpose of the system is what we call as abstraction. So we started thinking, what do we need the player need to know or able to do? Well, it needs to know its inventory. It needs to be able to locate objects or items within the world. It needs to be able to return full description. But of course, as I said before, it doesn't need to be able to know, it doesn't need to be able to study, or it doesn't need to know about mathematical functions or science fictions. We just minimize it to what is essential and what is needed for the program to perform. Inside the system, there is actually a bigger structure. Every object inherits from one another, and the highest in the hierarchy would be the object created by the programming language itself. Player, in this instance, it inherits from the abstract game object. Abstract is basically a class where not all its functionality is implemented yet. Later on, the class that is going to inherit from it will implement the function further. So with that in mind, inheritance is used for specification. There may be a lot of game objects inside the world, but we need to specify it further into player or item, and we can add more functionalities into this. For example, in here, it is able to locate, it is able to return its inventory on top of the functionality and data from game object, which was to return short and full description and to have its name. So it's a form of specification. After we form a class, we're then able to create its instances, such as the instances of items would be like fire hydrants, bananas, glasses, and even further we can inherit from the item, as I said before, such as in this case it's back. So it's able to assess all the data and functionality of its parent class. The opposite of inheritance is polymorphism, which means that the bag can be treated as its parent class. So it can be treated as an item, can be treated as a game object as well, which could be useful in some cases. A concept we have not touched on yet is interface. It follows the same principle as abstract, where it can define certain functionalities and can be implemented later. Only that in interface, we cannot implement it at all. It can only be defined. The advantage of using interface is that a class can implement as much interfaces as it wants, whereas with abstract or with other class, it can only be a class can only inherit one other class. Also, it actually doesn't make sense to have interface as an abstract or as a class, because sometimes different objects can't implement the same interface just because of one functionality. Like in this case, both objects might have inventory, but they're a different kind, so it doesn't make sense to logically group them together. Hence, we use the interface. But back to this again, bags can also be treated or polymorph as the I have inventory interface because it implements that interface. In order for our program to perform its intended function, all the objects need to interact or collaborate with one another. For example, between player and the item bag, there needs to be a collaboration for the player to be able to find the bag and to fetch it or to put it in its inventory. And so each of them would carry roles and responsibility. The role of the player would be as the finder or the locator, and the role of the bag would be as the object being found. And with that in mind, there are responsibilities that they carry. The player would need to be able to know its inventory, to be able to realize whether they already have the item or not, to be able to locate the bag. And in this collaboration as well, the item has the responsibility to know itself, to know its name, to know its description that it's going to store later inside the player's inventory. Another concept in object-oriented programming is cohesion and coupling. The best practice is to have high cohesion and low level of coupling. High cohesion means that classes have specific functionality. In this case, we could have bags and inventory joined together instead of being separately defined like this. But in order to have higher cohesion, bags need to focus on being able to locate the items, whereas the inventory will focus on storing and managing the items inside of it. Low coupling, on the other hand, means independency. So even though they're using one another and they're related to one another, they are still independent in a sense that their fields are kept private and they only provide particular methods as needed to the public. So bags are able to put items, are able to take items, are able to fetch items, but it doesn't have direct access to the item list on the private field. This is what keeps it low coupling, and it will make things easier later on when we want to modify the code. So to sum it up, object-oriented programming structures its data as objects. And objects can be created or define as a class. Each class will have fields and methods. Fields will define what the class or object knows, such as inventory and location in this case, and methods will define what the object does, such as locating in this instance. You can also inherit from game-object. You can also implement interface. Now, slightly different from class, you can also have field, you can also have methods, but those can only be defined. It cannot be implemented. So that would be the artifacts of object-oriented programming. Thank you for listening.